You've been there, right? You write this awesome Python script. Maybe it's a game that keeps track of your high score, or a simple tool that asks for your name. And it works perfectly. But then you close it, and the second you do, poof, everything's gone. Well, today we're going to fix that. We're giving your programs a memory.
I mean, really think about it. You fire up your script, you type in your name, you rack up some points, maybe make a to-do list. You're feeling pretty good about it. And then you close that terminal window. The next time you run it, it's like you were never there. All that info you just typed in is just vanished.
Exactly. It's gone. Just poof, it vanishes because it was only ever living in your computer's temporary memory. But what if I told you there's a super simple, really powerful way to make that data stick around for good? Well, that is exactly what we're diving into today.
All right, so here's our game plan. We're going to break it down into 5 easy steps. First, why does your data disappear in the first place? Then, we'll uncover the key to working with files. After that, we'll check out your file handling toolkit, actually build something together, and then you'll be all set to create whatever you want.
All right, let's kick things off with section 1. We need to get to the bottom of this core problem: temporary memory. I mean, why don't our programs just remember things automatically?
So, here's the deal. When your Python script is running, it's using your computer's RAM. Think of RAM as a digital whiteboard. It's this awesome, temporary workspace. You can scribble all over it, do your math, save names, track scores. But the second your program closes, it's like someone comes along and just wipes that entire whiteboard completely clean. If we want our work to last, we've got to write it down somewhere a bit more permanent.
And that permanent place, as you probably guessed, is a file. So the big question is, how do we get Python to actually talk to the files on our computer? Well, turns out we need a key.
And that key, my friends, is Python's built-in open function. Seriously, this thing is the master key. It's the absolute starting point for any file operation you're ever going to do. It lets you get into files, make new ones, change existing ones, but, a key is pretty useless if you don't know which way to turn it.
See, the open function needs to know what you want to do, and you tell it with something called a mode. R is for read. That's when you just want to look at what's inside an existing file. Then there's W for write. Now be careful with this one. It'll either create a brand new file or completely wipe out an existing one to start fresh. And finally, my favorite, A for append. This one is super useful. It just adds new stuff to the very end of a file without touching anything that's already there. Perfect for things like a high score list or a log file.
Okay, so in the old days, you had to manually open a file and then remember to manually close it. But that's kind of risky. What if your program crashes before you get to the close command? You could end up with a corrupted file. No good. That's why the modern, much safer way is to use the with statement. It's brilliant. It automatically and safely closes the file for you, even if things go wrong. Seriously, this is the way to do it. It's just best practice.
All right, so we've got the key. We've safely opened the door to our file. So now what? What can we actually do? Let's check out the toolkit you have for getting data in and out. First up, you've got the .read method. This one's super simple. It just reads the entire file, top to bottom, and hands it all back to you as one big block of text. It's fantastic for smaller files when you just need to grab everything in one go.
But what if the file is massive, like millions of lines long? Trying to load all of that into memory with .read would be a total nightmare for your computer. That's where .readline is a lifesaver. It does exactly what it sounds like. It reads just one single line at a time. This keeps your memory usage way down and makes it super efficient for chewing through huge files.
And then you've got .readlines with an S at the end. This one is kind of the best of both worlds. It reads all the lines in the file, but instead of smushing them into one giant string, it organizes them very neatly into a Python list. Every item in that list is a single line from the file. This is amazing when you want to loop through and do something with each line one by one.
And you can see the difference pretty clearly, right? .read just gives you one big string, complete with the new line characters. But .readlines gives you this nice, clean list, where each line is its own separate thing. Which one you pick really just depends on what your goal is.
Now, what about putting stuff into a file? Well, writing is just as easy. You've got .write, which, you guessed it, writes a single string to your file, and if you have a whole list of strings you want to save, like a list of tasks or scores, you can use .writelines to write all of them to the file at once.
Okay, that's enough theory. The absolute best way to really get this stuff is to see it in action. So let's put these tools together and actually build something.
What we're going to do is build a really simple script.
It's going to create a file called notes.txt. We'll write a couple of notes in there, and then we'll read it back just to prove to ourselves that it all worked.
So here's the plan, step by step. First, we'll use with open in write mode, that's W, to create our notes.txt file. Second, we'll use .write to pop some text in there. Third, the with statement will automatically close it for us. Then fourth, we're going to open that same file again, but this time in read mode, R. And finally, we'll read the contents and print them to the screen, just to confirm that our notes are safe and sound.
Okay, one quick but really, really important point. When we just use a file name like notes.txt, Python assumes that file is in the exact same folder as your script. That's called a relative path. It's simple, it's easy, but if your file lives somewhere else, like in your documents folder or on your desktop, you have to give Python the full address, the absolute path, starting all the way from the root of your computer's hard drive.
And honestly, just like that, you now have the fundamental superpower to make your Python programs remember things. You can save user info, create log files, store settings for an application. The possibilities are huge.
So let's do a super quick recap. What are the key takeaways? First, files are your program's permanent memory. Second, always use with open to keep things safe. Third, your three main actions are read, write, and append. And when you put all that together, you can build some seriously powerful data-driven apps.
So that barrier, it's gone. Your programs don't have to be forgetful anymore. Now you can save anything. High scores, user profiles, daily journal entries, whatever you can think of. So the only real question left is, what stories are your programs going to tell now?